Hi viewers, welcome to Briksham channel. Learn mathematics easily. In this video, we are going to discuss about correlation. What is mean by correlation? The definition says that the term correlation refers to the relationship between the two variables. Right? Here we are going to study about the relationship between the two variables, whether they are related to one another or there is no relation or there is no negative relationship between the two variables like that. That is how we are defined, we can say easily is whether they are friends or enemies or they are not at all related to each and everyone. Likewise, we are going to discuss that is known as correlation. Next definition is simple correlation. So here simple correlation means the relationship between two variables we are considering, right? So here we are going to study about relationship between only two variables. Next we will come on to types of correlation. So we have two different types. One is positive correlation and another one is negative correlation. So we will see one by one. So positive correlation, what is mean by that? The two variables change in the same direction, that is either both are increasing or both are decreasing. Both the values of the variables are either increasing or decreasing, then we can say it as positive correlation. That is, there exists positive correlation between two variables, right? So here we are given with some examples. So you just note the values of x and y. So in the first example, we can see that X is given as 64, 65, 66, 67, 68, 69 and 70, and Y is given as 66, 67, 68, 68, 70, 70, 72. So here we can see that both the variables X and Y are increasing. This is an example for positive correlation. Similarly, come to the next one, next table. So X ranges from X values, it is ranges from 34, 25, 18, 10, 8, 6, 4, and Y ranges from 51, 49, 42, 33, 19, 16 and 12. So here we can say that we can see that both the variables X and Y are decreasing. Therefore, this is an example of positive correlation, right? Another one given is in the day-to-day life, we can see the examples like sales and expenditure on advertisement. If we are spending more on the advertisement, we are advertising more about the products, we will get more sales, right? Therefore, that is a positive correlation between the two variables. The next one is yield and fertilizer applied. So how far we are taking care of the yield, we are taking care of the crops, we will get more yield, right? So therefore, this is a positive correlation. Next, we will move on to negative correlation. So it is opposite of positive correlation, which means that when we are considering two variables, if one variable is increasing and another one is decreasing, or otherwise the first one is decreasing and the second one is increasing. Likewise, if we have means, then we can define it as negative correlation. So first example says about the negative correlation. So here we are considering two variables X and Y, and the values of the variables are given. So X ranges from 65 to 78, it is increasing, and Y takes the values from 51 to 12, so it is decreasing. So while X increasing, the other variable is decreasing. Therefore, it is an example of negative correlation. Then in real life, we can see the price and demand. So once the demand is increasing, so once the price is increasing, the demand will be reduced, right? And the second one is number of members in a family. So if we have 4 members, we will spend more amount. If we have more numbers in a family, then the expenditure will be reduced. Monthly expenditure or packet money for each and every person will be decreased, right? Then next one, yield and weed. So once the weed is increasing, if we have more weed, then the yield will be decreasing. So this is an example of negative correlation. We have some other correlation types. Simple correlation. So here only two variables are considered under positive or negative correlation. Then we can say that it has simple correlation. That is, we are considering only two variables. Then we can call it as simple correlation. And partial and multiple correlation, if we have more than two variables, then we can classify it as partial correlation or multiple correlation. So what is the difference between partial and multiple correlation? So in both the cases, we are considering more than two variables. So what is the difference? So here we are considering in partial correlation, we are considering only two variables. Other variables we are keeping it as a constant, right? It gives the linear effect of all the other variables. Okay, so on we are removing all the linear effects, so we are considering only two variables, and all the remaining variables we are considering it as constant. This is called as positive correlation. And the example is given as the correlation between the price and the demand when the effect of income is removed from the partial correlation. Okay, so we are considering only the price and demand, we are neglecting the income. Okay, that is called as positive correlation. Next one is multiple correlation. So here also we are considering more than two variables, but while considering the variables, fixing the variables, one variable we are fixing, other one we are considering as a group of variables. We are not keeping it constant, we are considering grouping the variables. Okay, so that will give you the multiple correlation. So the example given is the correlation between demand and the estimate of demand. Why the demand is increased. Likewise, we are considering it is called as multiple correlation. Next one, linear correlation. So we are fixing, plotting the points in a graph sheet, right? And we are while plotting, if we are getting a linear effect, that is all the points lie exactly on the straight line or scattered around a line, then we can define it as linear correlation between the variables. Okay, linear correlation. So the given values we are plotting on a graph sheet. So all the points lie exactly on a straight line like this, or the points are scattered around the line, then we can define it as linear correlation, right? Next one, nonlinear correlation. Again, in this case also we are plotting all the values on a graph sheet. So all the points lie exactly on a curve. If the points plotted will form a curve, or the points are around the curve, then we can call it as nonlinear correlation. The next one, no correlation. So all the points are scattered around the graph sheet while plotting, then we can call it as no correlation between the variables, right? Then next we will move on to simple linear correlation methods. How to find the linear correlation, that is we are going to learn now. We are going to find the linear correlation by the four methods. First one is scatter diagram. Second one, Colpearson's coefficient of correlation or product moment correlation coefficient. Third one is Spearman's rank correlation coefficient. And fourth one is correlation coefficient by concurrent deviation method. So we will see one by one. First one, scatter diagram. So in this we are plotting all the set of values, that is all each and every pair in a graph sheet. So depends upon the lines, the points are merged. We are defining the. So here see the first one, it is perfect positive correlation. So perfect positive correlation means the line, that is the points plotted, will goes from left to the right, and the points are all the points are all on the straight line. Then it is called as perfect positive correlation. Next one is perfect negative correlation. Okay, so here also the points are from left to right, but it is in the upward direction. It is from top to bottom, and in the positive correlation it is from bottom to top. If the correlation, the points plotted will look like this, then we can define it as perfect negative correlation. So in perfect positive correlation, R will be equal to 1, and in perfect negative correlation, R will be equal to -1. Right. Next one is high positive correlation. So here also we are plotting all the values on a graph sheet, and positive means the line goes from bottom to top, and all the points plotted, it is around the line, then we can call it as high positive correlation. And high negative correlation, that is high degree of negative correlation means it is from top to bottom, and all the points are scattered around the line, then we can define it as high degree of negative correlation. So here the value of R lies between 0.5 to 1, and here -1 to 0.5. Next one, low degree of positive correlation. So here for all the positive correlations, the line goes from bottom to top, and the depends upon the points plotted or scattered, we will define it as exact perfect positive correlation, or high degree positive correlation, or low degree positive correlation, right? So in low degree positive correlation, the points are spread out along the line. This is called as low degree positive correlation. And in low degree negative correlation, we are plotting the points from, that is it looks like from top to bottom, and the points are scattered around the line little bit wider than the high degree of negative correlation. Okay, so here In low degree of positive correlation, the R value lies between 0 and 0.5, and in low degree of negative correlation, the R value lies between minus 0.5 to 0. It is given in the interpretation, we can see it. Next one, no correlation. So here look into this picture. So the variables x and y are plotted. All the points are in the forms a straight line, that is one either the vertical line or the horizontal line, or it does not forms any line, or it is scattered around the graph sheet. Then we can call it as there is no correlation. Okay, that is there is no relationship between the variables. Okay, so this is called as no correlation. Next we will come to the some problems. We are given with some problems, that is the values of the variables x and y. We have to find the correlation by using the scatter diagram method, right? So the x values are given as 1, 2, 3, 4, 5, and y values are given as 5, 10, 15, 20 and 25. Okay, so for this data now we have to plot in the scatter diagram. So what about the x values? So first we will draw the x axis and y axis. Point represents 1, 4, 5, and here 5, 10, 15, 20, 25. So now we will mark all these points: 1, 5, 2, 10, 3, 15, 4, 20, 5, 25. Now we will join the points. So all the points lie on the straight line. Therefore, we can say it as the correlation is R equal to plus 1. That is perfect positive correlation. All the points are lying on the same straight line, that is from bottom to top. Therefore, we can define it as perfect positive correlation. If you are comfortable, kindly like, subscribe and press the bell button for further notifications. Thank you.